So the next part is graph in motion. In physics, it is very important to understand the graphs to explain the motion of an object. So we use different types of graphs. In IGCSE, you use like distance time and the speed time graph. But now you will learn another thing. You will learn the displacement time graphs. You will learn the velocity time graph. And you will learn the acceleration time graphs. Like explaining the motion by using these graphs. The last was you studied about the distance time and the speed time graph. What is the difference here? For example, if I say an object, how the distance time graph will be different from a displacement time graph. For example, there's an object which covered 2 meters first, and then it take a U-turn and return back 2 meters. What is the distance covered by this object? What is the distance covered by this object? So the distance covered by this object is 4 meters because at first it traveled 2 meters and then returned back. But what about the displacement? The displacement is 0. But if you want to represent this motion in terms of the graph, and if I say the object is moving at a constant speed, I cannot say it's moving at a constant velocity because the direction changed. So it means the velocity has changed. But say the object covered, like in first second, it covered 2 meters and then it returned back. So if you want to represent the distance time graph for an object which covered total distance of the 4 meter with a constant speed, so it will be a straight line. But what about the displacement time graph? If I want to represent, so first the object covered 2 meters and then it returned back 2 meters, so the displacement is 0. So in a displacement time graph, if the direction changes, it means the displacement will decrease. But in a distance time graph, if the direction changes, there will be no change in the distance. So here, what happened? The object covered complete, like it covered total 4 meters and that same interval. But what happened here? First, the object covered 2 meters and then it returned back to the origin. So it has a 0 displacement when it stopped the motion. But what if this object move in opposite direction? Like if I say an object move further 2 meters. So if an object move further 2 meters, I want to represent a distance time graph. So the distance time graph will continue. But what about the displacement time graph? Because it is on the opposite side of the starting position. So this displacement will be considered as negative. So how we represent a negative displacement? So in a displacement time graph, we will use both parts of the graph, like positive y-axis and the negative y-axis. So as a result, when we draw a displacement time graph below the origin, which shows that the displacement is opposite to the original position. Like this will be negative 2 meters. So that's how the displacement time graphs also explain the motion of an object with a direction. But the distance time graph does not give any indication about the direction. And if you want to find the speed from a distance time graph, so what we do, if you want to find the speed of a distance time graph, we work out the gradient. And if you want to work out the velocity of a displacement time graph, we'll also work out the gradient. So gradient, displacement time graph, the gradient is a velocity. Speed time graph, the gradient is a distance time graph, the gradient is a speed. Displacement time graph, the gradient is the velocity. So first the object, so in a displacement, when we represent or show a displacement of an object, as we said, we have to use both axes, the positive and the negative. If the right-hand side displacement is positive, the left-hand side displacement must be negative. So example, first the object moved 2 meters. Then it returned back to the origin. But then it has moved 2 meters opposite to the origin. So negative 2 meters. So how we represent a negative 2 meter? We represent in this manner. So this is negative 0 and 2 meter. So even though it was moving towards left, but that so moving toward left, this displacement was decreasing until it reaches the origin. Once it reached the origin, now it is moving opposite to the starting point. That's why we took as negative. It is a negative, but because what will happen, the net, see, object is at this point, it covered 2 meters, okay? When it is coming towards the displacement, because when we measure the displacement, we measure the displacement from the origin, the start. So when we measure the displacement, so this will be the displacement here. So still the displacement is positive when the object is moving backward. The displacement is positive because we are measuring a displacement which is toward the right hand side. The moment it returned back, now the displacement is 0. When it is on this position, now the displacement from the starting point, when we draw an arrow, the displacement will be negative. So when object took a U-turn and coming back, when we were measuring a displacement, all the distances were on the right hand side for the displacement. That's why still it was in the positive axis. But when it move away towards the left, now the displacement is negative. Is it clear?
Yes.
So we can use a displacement time graph. Same thing, we can use a velocity time graph as well. Like to explain the motion of an object, we can use a velocity time graph, acceleration time graph. Now we have different shapes of the graph depending on how the object moves. And using these graphs, so let's talk about the displacement time graph. The gradient shows, for a displacement time graph, the gradient shows a velocity. So example, this is a displacement time graph, okay? And it is a horizontal line on the origin, or it can be above the origin, or it can be below the origin, all of them. What we can say about the motion of this object? What we can say, the displacement time graph, and it might be a positive displacement, negative displacement, or zero displacement, but it's a horizontal line. What I can say about the motion of this object? Good.
Stationary.
Good. That's right, Meerup and Hafsa, that it is at rest, the object is not moving. But how the positive and the negative displacements are related here? For example, if you are standing at position A and you are observing the object which is next to you, you're observing the object which is next to you, you're also observing an object which is on your right hand side, and you're also observing an object which is on your left hand side. So example, this object has a displacement of +2, this object has a displacement of negative, and this object has a displacement of 0. So if I sketch a graph for object which is next to me, then this will be the graph. If I sketch a graph for an object which is at rest on right of me, that will be B. If I sketch a graph which is on the left, then it will be C will be the graph. So that's a displacement time graph for an object which is stationary or not moving. Now we can have a graph, a displacement time graph, which might be a straight line. What you can say about this displacement time graph? If it's a straight line, the displacement time graph, remember the gradient or the slope represent the velocity. So if it's a straight line, what we can say about the velocity?
Constant.
So we can say it's a constant velocity. That's right. But velocity can be positive or negative. As we know, it's a vector quantity. How to identify whether a velocity is positive or negative? Then what you have to do, you have to work out the value of the gradient but there is no scale mentioned. So how you know the value of the gradient? So just take the 2 points, like, because this is a time axis, so this is the first point. The first point on y-axis will be y1, and the second point on the y-axis will be y2. If you find the y2 is above y1, if you find that y2 is above y1, so it means the velocity or the gradient will be positive without calculation. I can say that. And if you find that the y1 is above y2, then the velocity will be negative. So this object, because the y2 is above y1, so it means it has a constant velocity and the velocity will be positive. But if I draw another graph, if I draw another graph, so if we take another graph here, first, what about the velocity of this object? What is the velocity of this object? It's a straight line. So if it's a straight line, what is the velocity of this object? It will be constant, because straight line has a constant gradient, so it has a constant velocity. That is one thing. But what about the value of the velocity? Is the velocity will be positive or negative? How to work out that? The same way, if I take a point from x-axis till the graph line, and that will called as y1. Then I take another point, that will be y2. So you can see y1 is above y2. So if y1 is above y2, it will be a constant velocity, but it will be a negative velocity. What does it mean, negative or positive? Because when there is a motion, if in the motion, if the right hand side velocities are positive, left hand side will be negative. So even a displacement time graph can give us an idea about the trend as well as the direction of the velocity. Like either a velocity will be constant, zero, uniform, or increasing, decreasing, plus whether a velocity will be positive or negative. Is it clear? This idea about velocity from a displacement time graph? Any doubt or a question till this point? Another example, if we have a displacement time graph, so if we have a displacement time graph and an object, it's a straight line, and it starts with the maximum displacement and then decrease. What you can say about the velocity here? It's a straight line. Straight line means constant slope. So what we can say? We can say it's a constant velocity, because whenever there's a straight line, the slope is constant, so it's a constant velocity. But what about the velocity? Is it a positive velocity or a negative? Is it a positive or a negative velocity? So when we take like example, because this is a time axis, so when I draw the first line from the time axis, that point I will call that as a y1. Then I will draw the second point on the time from the time axis. The second point I will call that as a y2. So you can see the y1 is above y2. So when the y1 is above y2, means this is a negative velocity. So when y1 is above y2, the velocity will be negative. But if I have the same graph, So if I have the same, what is happening here? Look, in this is an example. Say you're standing at position A, okay, and you're observing an object which is approaching you. So if all the right hand side direction you consider as a positive, so all the left hand side direction you will consider as negative. So if this object is approaching you, what with a constant speed, so it will have some velocity like, or constant velocity, example 2 meter per second. But what will be the direction of this velocity? It will be negative. Why? Because the object is moving towards left. The displacement is decreasing and the object is moving towards left. That's why the velocity is negative. But it has a constant velocity. Is it clear? So it is important to understand the direction of the velocity from the displacement time graphs. If we have a displacement here and time, why is the displacement towards the right and the velocity toward left? Look, you are observing at position A and you see an object at this point. Because when you measure the displacement, you measure the displacement from the starting point. So if this is your origin, from the starting point, you observe this object. So this object might be, say, 4 meters away from you. So this object is 4 meters away from you on the right-hand side. As we are taking all the right-hand side direction as positive, so the displacement is example plus 4 meter. But what happened if this object is moving at a speed of, say, 1 meter per second or a velocity of 1 meter per second towards left? Because the velocity direction is toward left, that's why we don't say the velocity is 1 meter per second. We call velocity as -1. And when the object approaches, like object is reaching this point, so the displacement is decreasing. Like after 1 second, it will be 3 meter left. After 2 seconds, 2 meter left. 1 meter, and then it will reach the origin. That's why the displacement is positive, but the velocity is negative. Same way, if we have a displacement time graph in this manner, again, it's a straight line. When it's a straight line, what about the velocity here? Because straight line velocity is always constant. But what about the value of the velocity? Is it positive or negative? What about the value of the velocity? So when I draw the line, the first, that will be y1 and this will be y2. So y2 is above y1, so it means it is positive. And what is the example? What is the example here? You are at position A and you are observing an object. So the displacement is a distance from the starting point. So the displacement is negative. Maybe it's -4 meters away from you. But the object is approaching you with a speed of 1 meter per second. So velocity is positive because the velocity is on the right, but the displacement is toward left. That's why it is negative. So these are the graphs which shows that the object is moving at a constant velocity. Velocity might be positive or negative depending on the direction of the motion. Is it clear, this example?